Okay, so with limiting reactant, it's different than if we just have one thing that's exact. So a nitrogen and three hydrogens making two ammonia molecules. That's like that. We have exactly enough. We have three hydrogens, we have a nitrogen. It's going to make two ammonia molecules. And you can see in the jar, perfect. But now for this next slide here, we have the three hydrogens, the one nitrogen, making the two ammonia molecules. And it goes on like that, but we have some nitrogen left over. So what we're basically going to do is we're going to calculate what's going on here. So this would be an example of how you would do this with just food, which for some reason is a lot easier for people than actual chemicals. So go through this one and, talk about it with yourself. How could you make, this is an arrow, a sandwich from one piece of ham, two slices of bread, and what's left over, and, how many sandwiches can you make? All right, so with this reaction right here, what happens is we have 100 grams of CH4 and 100 grams of water. And we have to decide which one of these is limiting before we go ahead and find how much product. Doesn't matter which product, but we have to find the limiting reactant first. Now, in a lot of the previous problems, we were told that one of these was excess and use this one to find the product, and you had excess that. Well, that's easy then. We know what's limiting, what's excess. But if you're not given that, if you're just saying, hey, you get 100 grams of this and 100 grams of that, you got to determine which one's limiting. So one way you can do that is first take the first reactant, CH4, 100 grams of it, they give it to you, and go ahead and convert that into moles. And make sure that you just do it for 1 mole. Okay, I don't care what number is up here in the balanced equation, it's 1 mole. So we're going to have 6.25 moles of CH4. Secondly, what I'm going to do is I'm going to find out what I need of the second reactant, what I need of water. So I'm going to take that 6.25 moles of CH4, and I'm going to go to the balanced equation, and 1 mole of CH4, 1 mole of water. So of course, this becomes a little bit more involved. Oh my gosh. This becomes a little bit more involved when you don't have a nice 1-to-1 ratio. But whatever those coefficients are, that's what you're going to use. So 1 mole of CH4 is going to require 1 mole of water. We are going to need 6.25 moles of water. And I actually have people write down the word need. That's what I'm going to need to react with all of that. Step 3, what do you really have? You have 100 grams. And I really need to get that into moles. Sorry, that's 18. I need to get that into moles to actually be able to compare. So in this one, I actually have people write have. So I have 5.56. I needed 6.25. I don't have enough. So immediately we know that this is my limiting reactant and that is my excess reactant. Now, listen carefully, what if I had, instead of 5.56 moles, they started me out with, 1,000 grams of water. I had like 10 moles, okay, or more than 10 moles, but let's say I had 10 moles here. Well, I only needed 6.25, and if I had 10, I'd go up here. This would be, my water would be my excess, my CH4 would be my limiting. Now, whichever one is your limiting, that's what you're going to use to find your product. So if this is your limiting, which we see it is, we're going to use that. If it had turned out that I had like 10 moles of this stuff, and this was my excess, then this would have been my limiting, the CH4, and I would have had 6.25 moles of it. But in this case, we'll do another example. This one right here is my limiting. So we found out that water is limiting. Why do you do that? To find product. That's what we're going to do. So what we're going to do is we're going to take our 5.56 moles of water. Be careful, don't take the 6.25 moles of water. We needed that to react with all the CH4, but we don't have it. So what we're going to do is basically go and say that 1 mole of water is going to react with, what was it? I guess just 1 mole of hydrogen. I hope that's right for the balanced equation. And so we should get 5.56 moles of hydrogen. Okay. Actually, was there a 2 in front of that? I think there was just, no, there was a 2, darn it. Okay. So we're going to get 11 moles of hydrogen. Okay. So we can also take that and we can say that 1 mole is 2 grams and we should make 22 grams. Okay. How much excess reactant is left over? Well, if you looked up at the excess reactant, we saw that that was CH4. And we then have to find out what was actually used. So we started this out with that. We're going to subtract with what was used. Now, that's a little bit more difficult to find out, but it's not terrible. We are going to base it on the limiting reactant. Everything gets based on the limiting reactant. So, that's water. We're going to take our limiting reactant of water, 5.56 moles of water, and we are actually going to use it to realize that for every 1 mole of hydrogen, we need water, not hydrogen, water. We're going to need a mole of CH4. So it only goes to show that we are going to use, why do I keep writing the wrong thing here? That many moles of CH4. Okay, so every 5.56 moles of water that were used to find the product, we're going to look at the balanced equation and realize that for every mole of water was used, a mole of CH4 was also used. So we're going to subtract those and we will get 0.69 moles of CH4. Then we could also get that to grams. A mole of CH4 is 16 grams. We should have 11 grams left over. That'll be left over. So that one is how we do that problem. For this one, we have 25,000 grams of nitrogen. We're going to get it into grams or moles, and that's going to be 893. Step 2, we're going to find out what is needed of the hydrogen. And for every 1 mole of nitrogen, we're going to need 3 moles of hydrogen. So we are going to need 2,679 moles of hydrogen. That'll be need. In step 3, I'm going to take the 5,000 grams of hydrogen. I'm going to convert it to moles so I can actually compare and say have. That's what I have. All right, if I needed that, I only have that. This again is my limiting reactant. So I'm going to take 2,500 moles of hydrogen. 3 moles of that should make 2 moles of the product, ammonia. And we will make 2,500 times 2 divided by 3. 1,667 moles of NH3. And we could always get that back to grams by multiplying by 1 mole is 17 grams. Okay, I'm going to do this one in the next video.